This video shows how Southeast Community College has integrated LabView into its physics and engineering courses. During each of the labs, the students are encouraged to monitor real-time graphs while the experiment is taking place. In this example, you can see how the LabView VI is used to produce the graph and also control the heat pulsar, which is putting energy into the ice and water mixture. The VI also has several preset parameters, which allows the student not to worry about the beginning and ending conditions for the lab setup. This allows the student to pay attention more to what the graph is actually producing instead of monitoring the equipment. The idea behind this is that the student then gets a better understanding of the physics principles that are involved and are not paying so much attention to how the equipment runs that they are distracted from the actual experiment itself. In this lab example, students will be able to monitor the graph as they continue to put the heat in, and they see that the heat is going into melting the ice and not actually raising the temperature of the water. One of the advantages of having the VIs is that can be specifically targeted to highlight the different physical principles that we want to draw to the student's attention. One of the ways that this is done is that as the ice continues to melt, the water temperature stays almost at a constant value. Once the ice is melted, then the heat will go directly into the water, and you should see the temperature rise dramatically. The VI has been written so that they have a marker to indicate when the ice has melted, and you can see in the following example that marker being applied. In the real-time graph here, you can see how the water and ice mixture has risen in temperature only slightly since the very beginning. Soon the ice is going to melt, and then the student will be able to activate the marker on the graph. After the ice is melted, they would quickly notice how the temperature of the water begins to dramatically increase as the same amount of heat is continually added. The students continue to monitor this experiment up to a preset temperature, which is used by the VI to actually shut the heater off. With LabView doing most of the monitoring, the students just have to continue stirring and they can continue to monitor the graph in real time. In this particular experiment, they notice then the rapid rise in the increase of the temperature of the water after the ice has melted. Here the student will see how the phase change of the ice has affected the temperature of the water. With all the ice gone and the marker indicating where it was completely melted, they can easily see then the change in the water temperature as the graph is now quickly rising as the heat is continued to be put into the experiment. The student doesn't have to worry about shutting down the equipment as they've already preset the temperature in which the heater will be turned off. Once the heater is turned off, the students then wait for a thermal equilibrium and then can use the VI to selectively read off data points, which then they can go through and analyze the amount of heat that was used to melt the amount of ice that was put into the container ahead of time. The VI is written such that they can just use the cursor and then the information is read directly off of the graph. Here you can see the completed graph that's used by the students. Notice that the ice marker indicating where the ice melted is in place so that they can distinguish between the different regions of the graph. Also, they begin to use the cursor to read off particular temperature values, which will allow them to calculate the amount of heat used in both heating up the water and also determining the amount of heat used in the ice. The real-time cursor measurement allows them to pick different regions in which they want to read off particular temperatures and follow the discussion in the different parts of the graph.